So this is the third and final video in this quadratic series here. With the first video, we talked about basics about parabolas, quadratic functions, and then we graphed a function that was in vertex form. In the second video, we graphed a quadratic function that was in standard form. And in this third video, we're going to graph a function that is in intercept form. Okay, so intercept form looks like the following. Y equals leading coefficient A times two binomials here. Okay, notice coefficient of x is 1 in each. It's x minus p, x minus q, okay? So we're going to do a quick graph of a quadratic in intercept form, okay? As before, with all three forms, if A is positive, we've got a parabola that opens upward and we have a minimum value. If A is negative, we have a parabola that opens downward and has a maximum value. And the y-coordinate of the vertex will serve as that maximum or minimum value, okay? As with the other two forms, there's always something you can pull directly from the equation, okay? In vertex form, you could pull the vertex directly from the equation. In standard form, you could pull the y-intercept directly from the equation. In intercept form, you're going to be able to pull the x-intercepts, okay? P and Q directly from the equation, all right? You can find the y-intercept pretty easily. Just plug in 0 for x and then solve the resulting equation, okay? Now the vertex, again, we've got to do a little work just like we did with standard form, okay? The vertex x-coordinate is going to be the average of p and q, okay? We're going to add p and q together and divide by 2, okay? If you think about that concept of symmetry, that should make sense. The vertex should be halfway between, the vertex x-coordinate should be halfway between those x-intercepts, okay? Once you find the vertex x-coordinate, you're just going to plug that back into the original equation and solve for y, and that'll give you your vertex. That should be enough information to graph your equation. As always, you can use the axis of symmetry to help you complete that graph, okay? So we've got our given quadratic equation here. Y equals negative parentheses x minus 2 times parentheses x plus 1, okay? So which way does the parabola open? Again, our a value is negative 1, so a is negative, which means our parabola opens downward, and there's going to be a maximum value, okay? What are the x-intercepts of the graph, okay? So remember, our x-intercepts are going to be those values p and q, all right? Well, it's x minus p, so it's going to be the opposite of what we see here. This is x minus 2, so p is going to be positive 2. It says x plus 1, q is going to be negative 1, okay? So that's our p and q values. Therefore, those are our x-intercepts at 2, 0 and at negative 1, 0, okay? So very easy to find those x-intercepts there. The y-intercept, remember, is going to take a little bit of work, okay? We're going to plug 0 in to our original function. So we're plugging in 0 here for x and a little bit of work. So we've got a negative times a negative 2 times a positive 1, which gives me 2 times 1, which is positive 2, okay? So my y-intercept now is going to be at 0, 2, all right? So I've already got 3 points pretty quickly here that are going to help me graph, all right? The vertex, remember the vertex is going to be the average, the vertex x is going to be the average of those x-intercepts, okay? So the vertex x-coordinate is going to be p plus q, okay, 2 plus negative 1 divided by 2, which gives me 1/2. So my vertex x is 1/2, all right, which gives me my axis of symmetry as well. That's the vertical line through x equals 1/2, okay? And to find the vertex y, I'm going to plug 1/2 again back into my original function. Replace x with 1/2 here and here, okay? So that gives me y equals a negative, and then quantity 1/2 minus 2, times the quantity 1/2 plus 1, okay? I'm not going to show the steps of getting a common denominator. We should be able to do that if you're at this point. So we got 1/2 minus 2. Well, that's going to be negative 3/2, okay? Not sure why we doubled that up there. Negative 3/2, and 1/2 plus 1 would be a positive 3/2, okay? So I've got a negative times a negative, which makes this positive, and then I've got 3 times 3 in the numerator, which is 9, over 2 times 2, which is 4. So my vertex y-coordinate is going to be 9/4. So that gives me the coordinates of my vertex to be 1/2 and 9/4, okay? So remember, we've got a maximum value here, the parabola opened downward, so we have a max, and the max, remember, is going to be the y-coordinate of the vertex, which is 9/4, and that occurs at x equals 1/2, okay? So let's go to the graph. We've got two x-intercepts, we've got a y-intercept, and we've got a vertex that are going to help us graph. So we're going to have a really good picture of what this function looks like. All right, so we had the vertex at 1/2, 9/4, which I've gone ahead and made decimals here for you. So we're halfway between 0 and 1, and we're up about 2 1/4. Okay, just estimate that as best you can. Okay, let's go ahead and make our axis of symmetry. Again, that's the vertical line through the vertex. Okay, we found our x-intercepts to be at 2, 0. Okay. And then our other x-intercept was at -1, 0. Okay. And we've got those. So notice, those are symmetrically, they're equivalent distances from the axis of symmetry because they're symmetric points, okay? So that should be the case. If you don't have symmetric points there, then you've screwed something up, okay? We found our y-intercept to be there at 2, 0. Okay, so using symmetry, we've got another point equidistant from that on the right side. Okay, so those two green points should be symmetric again. My axis of symmetry is a little bit crooked, but you get the idea. Okay, and now I can just connect those points and I've got my parabola. Okay, so that's the quick graph of a function that's in intercept form.